If airplane wings are what create lift and keep the plane in the air, why do pilots obsess over the angle of the nose like their life depends on it? Stay with this, because it gets uncomfortable fast. They teach you that wings generate lift through air pressure differences. Air moves faster over the curved top, slower underneath, and the plane rises. Clean, simple, done. But here's what that explanation skips. If the wings are doing all the work, the nose angle shouldn't matter at all. Point it anywhere. The wings will figure it out. Except every pilot alive knows that's completely false. Pitch too high, the wings stall and the plane drops like a rock. Pitch too low, the aircraft dives. The nose attitude controls everything, which means something else is happening that the textbook version quietly leaves out. So here's the thing, if it's not just about the wings, then what really is going on when we talk about the nose angle and how the plane actually flies? Well, it all comes down to the relationship between the wing, the airflow, and that critical angle. It's not just the shape of the wing, but how you present it to the oncoming air. That little difference, the angle between the wing and the direction of the wind, changes everything. It's subtle, but honestly, it's the difference between flying and, well, falling out of the sky. Pilots live by this, because in the end, the plane doesn't care about the textbook. It cares about physics, and physics, mate, doesn't give second chances. And now here's the part that lands differently. Commercial pilots on long-haul routes are trained to continuously adjust the nose downward to, quote, follow the curvature of the Earth. But not one of those pilots has ever actually felt that adjustment happen automatically. It gets manually programmed into the autopilot by humans. If gravity naturally pulls the plane along a curved surface, why does it need to be manually entered into a computer? On a flat, stationary plane, none of this needs explaining away. The aircraft flies level. The horizon stays level. Nose attitude matters because the plane is managing real air pressure on a real flat surface, not constantly correcting for a curve that pilots can't feel, measure, or verify independently. The flat plane model matches what pilots actually experience in the cockpit, not what they're told to believe. Now, when you start looking at gyroscopes in aircraft, things get even more interesting. The way these instruments behave, well, it lines up with the flat plane idea, not with a constantly curving surface. Pilots and engineers have noticed this for years, and honestly, it's something that gets brushed aside far too often. Gyroscopes inside aircraft, before digital systems, would drift over long flights in ways that didn't match globe curvature predictions. Engineers called it gyroscopic precession. They built in corrections, manual corrections, for a curve nobody physically detected. That's not science confirming the globe, that's science patching a model that doesn't quite fit.